Hey guys, today we are going to take a look at PSoC Creator 4.2 and do a quick little demo just to make sure that everything works. Let's start by creating a new project. Now make sure when you're installing PSoC Creator that all of the updates are done and all of the device libraries are installed. So we have the CYHC Proto-063 BLE kit, and the module that's on that kit is this one, the 416045-02, and that is written on the board itself. So let's go next. We can just do an empty schematic for now. We don't need any of these. Let's create a workspace. Let's call it Senior Design. And let's call this Project Blinky. Cool. Now the PSoC has a dual core processor. One's a Cortex M0 Plus. It has a Cortex M4. And these are programmed from this main_CM0P and this main_CM4. And there's two main files because there's two processing cores. In addition to the dual core, the PSoC has a reprogrammable digital fabric, kind of similar to the FPGAs you guys have used. And you can program this in Verilog, but Cypress provides a bunch of pre-made blocks that you can also just use. Things like ADCs, digital to analog converters. CapSense is useful for creating capacitive touch sensing buttons. Communication blocks, Bluetooth. I2C is useful for talking with various sensors. SPI, UART, a lot of digital functions. So like PWMs are useful for making LEDs brighter and dimmer. You have counters, a bunch of logic gates, AND gates, NOT gates, OR gates, as well as registers and a lookup table. So if you wanted to create a state machine, you could. And keep in mind that the reprogrammable fabric runs independently of either of the two cores. So you could technically have both of these cores asleep and all of this would still be operating. Let's take a look at, so yeah, let's add an input pin. And how about let's connect this to a button on your board. And so let's call this guy button. And let's add an output pin for the red LED. Let's call that red light. And let's also add an output pin for the other light you have on the board, which is your green light. And you know what, just for fun, I'm gonna put a NOT gate here. Cool, let's wire these guys up. All right, so now PSoC doesn't know what actual pin on the board this represents. And so the next thing we're gonna do is let's actually find out what pins those are connected to. So I'm gonna Google the name of the board, which is the Proto-063-BLE. It's this guy. And let's see if they provide schematics. Yeah. So here's the schematics for that board. Now this is the schematics for the entire board. We don't need to know a lot of this. However, let's just find the parts that we kind of need, which is the user button, which is this guy, and the LEDs. So it seems like the user button is connected to pin 04. And so let's go ahead and change that. Now, all of the pin assignments are done inside of this design-wide resource file. And so we're going to connect button 204. And it looks like the LEDs are connected to 6.3 and 7.1. So we'll do 6.3 and 7.1. Cool. Perfect. So I'm going to go ahead and compile this. Now, while that's compiling, let's take a look at some of the stuff in PSoC Creator. So we've kind of looked at this. This is basically how you map the various GPIOs on your schematic design in the reprogrammable fabric to the physical pins on the PSoC. You also have these other tabs. One is to configure all of the analog, let's take a look at clocks. These are the various clocks that run the PSoC, and so we can create new clocks if we want to. We can change the clock speed of each processing core if you want to save power, for example. All of our interrupts. So we have our two processors, the CM0 and the CM4, and this will list all of the interrupts that are used to sometimes wake up the CPU, sometimes to run various interrupt service routines. System has stuff like VDD, what's the VDD voltage? But mostly you'll be using this one. Now if you take a look at our project here, so we have Blinky. It's divided into our top design, which is our schematic, our design-wide resources, which we saw here. We have all of our files for Cortex M0 Plus, and we could take a look at some of these. So each of the Cortexes has a main file, just like you would have an int main in a normal C code. This is the main file for the Cortex M0. You likewise have one for the Cortex M4. This is where you write the code for that. And these obviously both run independently, and they can both interact with the reprogrammable fabric independently as well. Cool, so compilation is done. Let's go ahead and program it. Now, it's giving you the option to select either the Cortex M0 Plus or the M4. It doesn't matter which one you pick. Usually you pick the one that you're going to debug because that's the one the debugger is connected to. So let's do the Cortex M0 Plus. When you press the button, the red LED comes on, and when the button's not pressed, the green LED comes on.